Hey everyone, so today we're going to be solving more complex absolute value equations. Yesterday we looked at pretty basic ones where the absolute value bars were already isolated. So today we're going to focus on isolating and then solving. All right. So this slide is actually the exact slide from yesterday's video, solving absolute value equations. The first step, isolate the absolute value expression on one side of the equal sign. It is not always by itself, which is a skill that we're really going to focus on today. Then we are going to solve two equations where we take our expression in the absolute value bars and we take it out of the bars, set it equal to a positive value, and then we also set it equal to a negative value and solve two separate equations to find our two different answers. And then from there, you can check your solutions to see if you got the right answer. All right, so let's get started. We have example 1, 6 minus 5 times the absolute value of 2x minus 7 equals negative 24. So the first thing I like to do is draw those train tracks. Now, a lot of people's first instincts are to distribute into this absolute value bar, which is what we're not going to do. We're going to treat this like these are little walls that you cannot go in. We're going to treat that you cannot do anything inside of that. Treat it like a variable, treat it like something that, anything that we cannot go into. So the first thing we're going to do is we are going to move this 6. And if you want to rewrite this so you can kind of see the thought process behind this is 6. I'm just rewriting this in a different way so you can kind of see where my logic is coming from. So I rewrite this equation as 6 minus 5y equals negative 24, where I'm basically treating those absolute value bars like its own variable. Okay, so if we were solving this equation, the first thing we'd want to do is subtract 6 on both sides, which is what we're going to do first. Okay, so I'm going to subtract 6. That is going to give us negative 5 times the absolute value of 2x minus 7 is equal to negative 30. Different signs, same signs, add and keep. Okay, so now it's kind of like we have negative 5y equals negative 30. If we treat this like its own variable, right? So what we would do next, I'm actually going to write it so you can kind of see it up here. And if that confuses you, just don't even follow it. It's just so you guys can kind of see I'm treating this like its own variable. And there's a negative there. Okay. So what we would do next to isolate y, we would divide negative 5 on both sides, which is the same thing we're going to do here. We want to isolate those absolute value bars, so we're going to divide negative 5 on both sides. So we're going to get those cancel. We get the absolute value of 2x minus 7 is equal to negative 30 divided by negative 5 is a positive 6. All right. So that was that entire first step from the last slide. We just isolated the absolute value bars, so now they don't have anything outside of them on this side of the equal sign. So what I'm going to do next is we're going to solve it the way that we solved yesterday. I'm going to just rewrite it. Oops, that is a 7, not a 1. It's my fault. Equals 6. And the way we do that, like we did yesterday, is we're going to create two different equations and solve them separately. Take your expression out of the absolute value bars, set it equal to a positive value. Out of the absolute value bars. And equal to a negative value. And we solve from there. So the first thing we're going to do is draw our train tracks over here. Let's add that 7 to both sides. That cancels. So we get 2x equals 13. Last step, isolate that x. So you're going to divide by 2 on both sides, and you're going to get x equals 13 over 2. We cannot simplify 13 over 2. That's a fraction that doesn't have any other number besides 1 that can go into them. So we're going to just leave it as 13 over 2. I'm going to do the same thing over here. Draw your train tracks. Add 7. Add 7. That cancels. We get 2x is equal to a positive 1. Negative 6 plus 7 gives us 1. Okay, let's isolate x. Divide 2 on both sides. So we're going to get x equals 1 over 2. That's a number I can't simplify, so I'm going to leave it just like that. If you want to write these in decimal form, that's fine too, but I'm going to just leave it as a fraction. So let's just summarize real quick what we did here. We isolated our absolute value bars by first moving the constant. We subtracted it on both sides, and then dividing the coefficient. I'm going to treat that just like a coefficient to isolate those absolute value bars. Then from there, we created our two equations where we took our expression out of the absolute value bars, set it equal to a positive, out of the absolute value bars, set it equal to a negative, and then just solved that two-step equation. All right, let's take a look at one more example. Okay, so I'm going to do the same thing where I'm going to kind of treat this like its own variable. So I'm going to circle this so we know we can't touch anything inside this equation. So this, I'm going to treat it very similarly to negative 2x. Actually, no, I'm going to call that y. I'm sorry about that. I don't want to call it the same variable that we're using in the actual equation. Plus 5 equals negative 13. So I'm going to treat this, so all I did was instead of writing these absolute value bars, I wrote y, because I'm going to treat this like its own variable. We're trying to isolate it. So if we were looking at this equation, the first thing we would do to isolate y would be subtract 5 on both sides, which is what we're going to do first here. So I'm going to draw my train tracks. And let's isolate that absolute value. Let's subtract that 5 on both sides. So then we're left with negative 2 times the absolute value of 3 minus 5x is equal to negative 13 minus 5, same signs, add and keep. You're going to get negative 18. All right, so I'm going to just reflect that over here. So now we have negative 2. Remember, I'm treating that like a y equals negative 18. Okay, so if we were solving this, we would divide negative 2 on both sides because we want to get y by itself. So we're going to do the same thing. We're going to divide by negative 2 on both sides. So that's going to cancel out here. So we're left with 3 minus 5x in our absolute value bars. And then negative 18 divided by negative 2 is a positive 9. Okay, now our isolation is done. The absolute value bars are by themselves on one side of the equal sign with nothing outside of them, just some stuff inside of them. Okay, so from there, I'm going to solve the way we solved before. I'm going to just rewrite it over here. And we're going to create those two equations like we did last time. So 3 minus 5x equals a positive 9. And then we have 3 minus 5x equals negative 9. So we're taking it out of the absolute value bars, setting it equal to a positive, and then setting it equal to a negative value. Okay, let's draw those train tracks and start solving. So first we want to move our constant, so we're going to subtract 3 on both sides. So we end up with negative 5x equals 9 minus 3 is 6. Okay, let's Get that negative 5 out of there. Let's divide it on both sides. That cancels, so we end up with x equals negative 6 over 5. That's a fraction we can't simplify. A positive divided by a negative would give you a negative, so we're going to leave it negative. All right, let's solve the other equation. Draw your train tracks. Let's subtract 3 on both sides. So we get negative 5x is equal to negative 12 here. Let me just continue those. Remember, same signs, add and keep. All right, so now we want to get rid of that negative 5. Let's divide on both sides. That cancels. So we're left with x equals a negative divided by a negative is a positive. So we're going to just leave it as positive 12 over 5. Box that up. All right, so just real quick, let's see what we did. We isolated our absolute value bars first by adding the constant to get that plus 5 away from the absolute value bars, and then dividing by the negative 2 on both sides to get those all by itself. And then once they were by itself, we separated it into 2 equations where we set it equal to a positive value and then equal to a negative value, and then just solved that two-step equation from there. So it's super important. Make sure you isolate your absolute value bars before you start solving them.